Instance. Not far away, the workers between 22 and 25 years old move slowly around the landing gear and engine compartment as
tangents. That clean and disciplined environment makes many people believe that modern aviation almost no longer leaves room for mistakes.
Why is such a tiny fluctuation enough to make the entire team stop the inspection process completely? In aviation, accidents rarely begin with a massive explosion happening suddenly, but instead usually start from a small... That is why airlines around the world are entering a silent but enormous transformation, where the goal is no longer simply to repair failures after incidents appear.
The new goal is to prevent dangerous surprises from having the opportunity to appear in the first place, by allowing aircraft to understand their own condition better than humans once did. That is why smarter aircraft systems are gradually changing the entire way the aviation industry operates, from the cockpit to the maintenance hangar behind the terminal.
And the biggest question begins to appear in the quiet atmosphere of the maintenance hangar about why the future of aviation needs fewer surprises.
For many previous decades, most aviation systems were designed based on a fairly simple principle that pilots and engineers would handle situations once failures actually appeared. Aircraft were built with countless checklists, warnings, and emergency procedures to ensure that humans could respond accurately when unwanted situations occurred in the sky. Old aviation thinking did not try to completely eliminate surprises, but instead focused on the ability to control the consequences of surprises. That approach once worked very effectively during a period when the number of flights was much lower than it is today. And
Dystonics are tracked. Every day, tens of thousands of flights operate simultaneously inside a complex network.
In that environment, even a tiny data deviation or a delayed decision lasting only a few minutes can
increase. The workers removing and inspecting a sensor assembly beneath the aircraft wing clearly understand that modern aviation...
Therefore, new intelligent systems are created not only to warn about failures, but also to predict what may happen before failures even begin to appear.
Modern aircraft can record millions of parameters during flights, from engine temperature to the smallest vibration inside every control system component.
All of that data is sent back to analysis centers so that engineers behind the terminal can understand exactly how the aircraft changes after every hour of operation.
But precisely at the stage where everything seems more advanced than ever before, a new contradiction begins to appear inside the future aviation industry.
Systems are becoming increasingly intelligent, yet the enormous amount of data also makes humans more vulnerable to overload from thousands of warnings and signals appearing simultaneously. The East Asian female engineer looks at the screen crowded with technical information and admits that sometimes the hardest thing is not lacking.
In many aviation incidents, warning signals already existed very early but became buried among countless pieces of seemingly normal data that nobody...
This is exactly why the aviation industry has started fearing surprises more than ever. Because the more complex systems become, a tiny sensor failure can cause incorrect data to spread through many different systems and then create a chain of incorrect decisions from the cockpit to the technical operations center.
The most frightening part is that humans often only see the consequences at the final stage, while the true cause had silently appeared long before.
The workers inside the hangar continue working with stable rhythms, yet beneath that calm atmosphere are hundreds of procedures designed... That is the moment when the central question becomes clearer than ever about why smarter aircraft systems also mean that the aviation industry needs fewer surprises. The biggest goal of intelligent systems is not to replace humans, but to reduce the number of unknown conditions before flights take off.
New systems use continuous data analysis capabilities to detect tiny abnormal trends that humans can hardly recognize through normal vision or experience.
If an engine begins vibrating differently by only a few % compared to its own standard dirt condition during previous flights,
if the temperature inside an electronic component increasingly little over several weeks of operation, the system...
That means future aviation is shifting from a model of repairing after failures into a model of predicting failures beforehand.
The female engineer looks at the historical aircraft operation graphs and realizes that modern aircraft are almost telling the story of their own.
Workers no longer only disassemble and inspect through traditional mechanical instincts, but instead work alongside analytical systems capable of detecting risks before humans can see obvious signs. The fewer surprises there are, the more time pilots have to make accurate decisions instead of being forced to react under extreme pressure.
That is also why airlines are investing heavily in intelligent self-monitoring systems. Because
in aviation, stability does not appear because of luck, but is built through the ability to detect abnormalities before conditions. As the matte gray narrow-body aircraft continues resting beneath the cold lights of the maintenance hangar, everyone begins to understand that that transformation is not simply about upgrading software or installing additional sensors on modern aircraft.
More importantly, the mindset of the entire industry is changing from reacting into proactively eliminating surprises from operational systems.
The female engineer remembers a time many years ago when technical teams usually waited until aircraft showed obvious failures before beginning repairs or replacements. Today, intelligent systems attempt to predict failures many days or even weeks in advance so that aircraft never have to enter truly dangerous conditions.
That difference is similar to detecting an illness from its very first small signs, instead of waiting until the body collapses before starting treatment.
Future aircraft will no longer be silent machines waiting for human inspections, but instead will continuously communicate with technical teams on the ground.
the young workers inspecting the landing gear assembly understand that they are no longer working only with mechanical tools, but are becoming part of a continuously operating global aviation data network.
Smarter systems also reduce emotional decisions because every evaluation is based on the real operational history of each specific component on each individual aircraft. That allows future aviation to depend less on assumptions and gradually reduce the possibility of situations where humans become completely surprised.
Because a system capable of repairing failures is still not the safest system, while a system capable of detecting risks before...
The future of aviation does not lie in creating more powerful machines, but in creating systems that understand themselves more clearly.
Onto it. The female engineer realizes that every safe future flight will no longer depend too heavily on last-minute reactions. But
the workers continue working inside the clean and quiet environment, as if every procedure there is trying to eliminate every remaining surprise from the modern sky little by little. The aviation industry has learned through many decades that humans always have limitations when reacting to situations appearing too quickly or becoming too complex.
We have a critical failure on auxiliary control. Get the manual override now. I need power diverted to the stabilizers immediately. Hurry!
And that is exactly why the future of aviation needs fewer surprises. Because in a world where everything is becoming increasingly...
And that is exactly why the future of aviation needs fewer surprises. Because in a world where everything is becoming increasingly connected and complex,